Hello and welcome to this video on what is latent profile analysis. My name is Geiser, I'm an instructor with QuantFish, and on this channel I present weekly statistics tutorials. I usually talk about multivariate statistical methods including factor analysis, structural equation modeling, multi-level analysis, and latent class modeling. If this is something that interests you, then please subscribe to this channel. Also, don't forget to check out the description for additional resources, including classes that I teach for QuantFish. So in this tutorial here, I want to introduce you to latent profile analysis. And this is a very basic introduction that is mostly conceptual for people who have never heard of latent profile analysis or barely heard of latent profile analysis and want to find out what that is, what this is good for, and if this is something that maybe you could use in your own research. So what is latent profile analysis? In order to address that question, it is useful to look at latent profile analysis in the context of other latent variable types of statistical methods. And so I like to use the following table for this purpose, where we contrast observed variables in the columns with latent variables in the rows, to see what types of different statistical models we have available for latent variable modeling with different scale levels on the side of the observed variables and also different scale levels on the side of the latent variables. And so here you can see that when we have observed variables that are categorical here meaning binary, dichotomous, or ordinal, ordered categorical, and the latent variables are also categorical, for example, also nominal categories, then this is called classical latent class analysis. So latent class analysis is a type of latent variable analysis that extracts unknown subgroups or types from categorical item response patterns, from dichotomous items or from ordinal items. When we have indicator variables that are continuous and we're still interested in extracting so-called latent classes or previously unknown groups, then we call this latent profile analysis. So really the only difference between classical latent class analysis and latent profile analysis is that with latent profile analysis we're using indicator variables or observed variables that are measured on an interval scale, meaning they are sum score variables or mean scores for a questionnaire or something like that. So something that is not binary or ordinal but can be viewed as continuous or metrical, we could say. So continuous variables are used as indicator variables to extract latent subtypes, and we will see shortly what exactly that looks like in concrete terms, what the parameters are that we obtain from such a latent profile analysis. So latent class analysis and latent profile analysis have in common that they use categorical latent variables, but they differ in that classical LCA uses categorical indicator variables, whereas latent profile analysis uses continuous indicator variables. Now, that being said, I should already warn you that this difference really is not that clear-cut anymore nowadays, because there are software programs now that can easily handle a mixture of binary, ordinal, and continuous indicators of latent classes in the same type of analysis. So for example, in Mplus, which is a software program that I have a bunch of videos here on this channel about latent class and latent profile analysis, Mplus is able to handle different types of scale levels on the side of the observed variables with ease. And then how do you call that? So then it's a mix, a hybrid between classical latent class analysis and latent profile analysis. So really that difference is not always that clear cut. You can use a mixture of categorical and continuous indicators as well. Now, on the side of the continuous latent variables, we have on the one hand methods of item response theory, which are designed to handle binary variables or ordinal variables, for example, Rush model or a 2-parameter logistic model. Those are IRT models that have a single latent variable that is continuous, so-called latent trait variables, and they use categorical indicator variables to extract continuous latent variables. Also, there are methods of factor analysis for binary and ordinal variables that can be used that are similar to item response theory models, but are in the tradition of factor analysis and structural equation modeling, SEM. And then finally, we have classical factor analysis and SEM for continuous indicator variables. And also there we have continuous latent variables. So now you can see how latent profile analysis relates to other types of latent variable models. And so the main special thing about latent profile analysis is that the latent variables here are categorical, not continuous. So we don't have latent factors, but instead the values of the latent variables are categories or groups. And so that contrasts LPA to IRT methods or factor analysis methods, which assume that the latent variables are on a dimension, that they are continuous. And then classical latent class analysis uses non-continuous indicators, uses discrete indicators that are binary or ordinal. We can also think of latent profile analysis as a mixture distribution model. And in statistics, we have a whole bunch of different mixture distribution models. For example, we have mixture regression models, we have growth mixture models, we have latent class analysis, latent profile analysis, latent transition analysis. So whenever we assume that there's population heterogeneity, meaning when we think that our population consists of qualitatively different subpopulations, like you can see here in this picture, where these groups differ in color, so to say. So that would be a qualitative difference. There can also be quantitative differences that could be reflected in latent classes and in these mixtures. But primarily, mixture distribution models are concerned with identifying qualitative differences, so differences in kind rather than in degree between individuals in a given population. And so the idea then of the analysis is to unmix the population and to find homogeneous subgroups, the so-called latent classes. So it's like cluster analysis, where we want to find clusters of individuals that are homogeneous, where each cluster in itself is homogeneous, but where there's a difference in kind or in degree between those clusters. So it's finding, basically the goal is to find previously unknown groups that have distinctive features. And so with latent profile analysis, we do that by using continuous indicator variables. We can illustrate latent profile analysis in a similar way as a factor model with a path diagram and indicators in boxes. So here, for example, in this example, I have 5 indicators that are the subscales of a questionnaire that measures the big 5 personality traits: emotional stability, extraversion, openness, agreeableness, and conscientiousness. So those would be scale scores, sum scores, or average scores, for example, from a questionnaire. And so then I have a latent class variable that indicates the personality type. So this would be the variable that I want to extract based on the associations or correlations between those scale scores among those latent class indicators that are my test or questionnaire sum scores. And the idea is very similar to factor analysis in that the latent class variable is supposed to explain or account for the covariances or correlations between those indicator variables. So there should be, so say after we partial out the latent class variable, there shouldn't be any residual associations between those indicators ideally. So the latent class variable should account for those associations. And so unlike factor analysis, we're not trying to find, so say, out how many factors there are to explain the associations properly between the variables, but instead the goal is to find out how many classes we need. So how many different groups are needed to sufficiently account for the relationships between our variables. So with factor analysis, we are grouping items or variables, whereas with latent profile analysis and latent class analysis, we are grouping individuals. So we're classifying or categorizing individuals into homogeneous groups, whereas with factor analysis we're trying to find groups of variables that measure similar attributes in terms of underlying dimensions. Now, let's also take a look at the formal LPA model equation so that you can also learn a little bit about the math behind latent profile analysis. And so here you can see in this somewhat cryptical looking equation, we have on the left-hand side a symbol F that symbolizes the distribution of a set of scores. So yi indicates a whole set of scores given model parameters, and so theta indicates a set of model parameters. And so what that says here is that the distribution of our variables, for example the big 5 scores, is a function of a class proportion parameter, gamma c. So that's the one type of parameter that latent profile analysis, or the first type of parameter that the latent profile model estimates, is a class size or class proportion parameter that gives the size of a given class C. So that's one aspect, so to say, of that observed variable distribution. And then the other part is that there's a class-specific distribution. That's the right-hand side term, FC. So FC indicates a class-specific distribution of these scores. So the idea is that in each latent class, there can be a different normal distribution with a different mean, mu, c, or different means, and a different covariance matrix, sigma c. So the sigma c here indicates the covariance matrix with the variances in the diagonal of the matrix, and then off diagonal all the covariances between the big 5 scale scores. And so the idea then is that the distribution, so say, that we observe in the entire population is a function, so say, of a mixture distribution where it depends on what class we're looking at, and then in each class there could be a different set of means, a different mean vector, and a different covariance matrix. And so a goal of the analysis is to estimate those class proportion parameters for each class. They sum up to 1, so the classes are exhaustive and mutually exclusive, meaning that every person is only in one class, and also each person has to be in a class, so nobody is left behind. And so therefore these class proportion parameters sum up to 1.0 or 100%. And then second, we estimate those class specific means, variances, and covariances for our latent classes. And specifically the main interest usually in latent profile analysis is in the means, so the mean vector mu c, because that is what distinguishes the profiles between classes, and we will see that shortly in our example. So really we care about what or in which way those classes differ with regard to their means across the set of indicator variables. However, the covariance structure can also be modeled. So we can also have class-specific variances, and we can have class-specific covariances. Typically, however, we assume that the covariances are 0 in each class, because the covariances between the indicator variables are supposed to be explained by the latent class variable. So ideally, we have no residual associations between the indicator variables within class, but there could be different variances. So variances and means are estimated in each class. Covariances are often not estimated. They are set to 0. And then the variances can either be held equal across classes, which some programs do by default, like Mplus, for example, or the variances could be freely estimated across classes in the same way as the means are usually freely estimated across the different classes. So that's what the LPA model looks like. So there are these different types of parameters. The class size parameter is key so that we can learn how large each class is, the relative size of each class, and then we are interested in the class-specific means so that we can look at our profiles and compare the profiles across classes, and then also we could model the covariance structure as well if we like. Now, one question that you probably have by now is, how do we find out how many classes we need? Because this class proportion parameter itself, so say, only gives us the size of the classes, but it doesn't determine how many classes there should be. This is something that we have to decide, and the way it is typically done is either based on theory. If you have a theoretical model, a typological model that predicts a certain number of classes, then you can test that in a confirmatory kind of way. Or if you don't have any idea, if it's more exploratory, then you would typically estimate a 1 or 2 class model, a 3 class model, 4 class model, 5 class model, and so on. And you would compare the fit of these models, for example, by using information criteria such as the Bayesian information criterion, BIC, or likelihood ratio difference tests that can be used to compare the number of classes as well. So that's basically done based on fit statistics that you determine the number of classes, and then you pick a specific model that you think fits best and interpret the parameters for that model. Now let me give you an example too, so that this becomes a little bit more concrete. And so there's, for example, in personality research, a theory about 3 personality types. You find some references here at the bottom. And so in that 3 personality type theory, there are resilience, over-controllers, and under-controllers, and they are extracted or found based on the big 5 personality scale scores or factor scores. And so here you can see on the x-axis I have the big 5: emotional stability, extraversion, openness, agreeableness, and conscientiousness. On the y-axis I have the class-specific means. So those are the μc parameters from the previous equation that have been estimated for a set of data here for each class. And so we can see that there is one class, the resilience, that has high means across all of the big 5. So they're high on emotional stability, high on extraversion, high on openness, high on agreeableness, high on conscientiousness. So wonderful people who are not nervous, who are open, agreeable, extroverted, conscientious, so perfect, so to say. So those are that's a desirable group, so to say. We have desirable personality characteristics that are supposed to be healthy and useful. And so in this sample, it was estimated that there are 37% who fall into this category with averages that are high across all big 5 traits. The over-controllers, in contrast, are lower on everything compared to the resilience, first of all, but then they are also particularly low on openness here, as you can see. They are lower on emotional stability, they are lower on extraversion, they're pretty high on agreeableness and conscientiousness. So they're more neurotic, so to say, but they are agreeable and conscientious, so they're well functioning, so say in that regard, but they may not be as happy, so say, as the resilience, because they are more neurotic in a way and over controlling things. And then we have another profile that is sort of like the exact opposite of the over controllers. Those are the under controllers, who are higher on emotional stability, albeit lower than the resilience, and they're also higher on extraversion than the over-controllers and higher on openness, but they are lower on agreeableness, and in particular, they're very low on conscientiousness. So they are under-controllers, they are sort of like a little bit chaotic, and they have a pattern that is pretty much the exact opposite of the under-controllers, and it's also very different from the resilient personality type. And so this model with the 3 personality types is useful to group individuals across these big 5 dimensions. So this shows you that latent profile analysis really is a multi-dimensional method or multivariate method that looks at different dimensions and then how people, what configurations of scores people have across multiple different dimensions. And that can be quite interesting, in particular when it reveals qualitative difference between individuals in that regard. Now, notice that albeit these, although these 3 profiles look very distinctive, of course there's variability within each class, and variability can be huge. So that's not depicted here, but there's of course variance allowed within each class, and so not every resilient looks exactly like the pattern here, but there are differences. The individuals group around these profiles. And so one other goal of latent profile analysis is to find out how homogeneous these profiles are, so how reliably individuals can be classified according to their profile, and there are statistics that allow us to determine the probability with which each individual belongs to each of the latent classes based on their observed pattern or their observed profile, and so that way we can also find out how good our classification is based on the latent profile model, and we can classify individuals based on their most likely latent class or latent profile membership, which is also a useful aspect. For example, for diagnostic purposes, we could use a latent profile model to assign individuals. For example, in clinical psychology, we might be able to identify patterns of scores that indicate pathology or a disorder, a mental disorder, and so that can be usefully applied also as an individual diagnostic tool here. Now notice that we have the class sizes for each of the groups here in the legend in percent, and so notice that these add up to 100% here for this model, and that's always the case because individuals have to be in one and only one latent class. And so now, of course, this is a limitation of the analysis because squeezing individuals into just 3 groups, this is based on several hundred individuals, that's of course an oversimplification most of the time. So usually there will be additional subgroups that may be small, that may be different, and so we are simplifying here by grouping individuals into so few groups, but it can nonetheless be useful to summarize the data and find out about qualitative differences that are very pertinent in such data. Now this already brings me to another point here that I want to mention, and that is that this is a large sample technique. So you don't want to do this with 30 cases or 40 cases or 80 cases. So this is something where you would want to have several hundred cases to do this in a meaningful way. I would say probably at least 200 cases and preferably more than that to get reliable results. In summary, latent profile analysis is a latent variable technique that uses one categorical latent variables and continuous observed variables to extract those latent profiles. So we have continuous sum score variables or average score variables that we use as indicators, and based on those we extract latent classes or latent groups. One goal is to classify individuals into homogeneous subgroups, types, or classes, and to figure out how many classes we need to describe the data adequately, and then potentially also classify individual people to find out what group they belong to. The parameters of the model are the class size parameters or class proportions, gamma c, as well as the class-specific means and potentially class-specific variances and covariances that could also be modeled. So we could model a whole covariance structure for each class in different ways. In extensions of this model, we could add covariates to the model. We could have predictors of class membership to find out what determines, for example, whether somebody is resilient or over controller or under controller, and are there gender differences, maybe are there age differences. We could also look at consequences of class membership. So for example, mental health outcomes could be studied to see whether resilients have better depression scores, lower anxiety scores maybe than the other groups, for example, or other outcomes could be studied. We can also look at this model longitudinally, so we could have a latent profile transition analysis where we look at the classes at several different points in time and study transitions to see how stable those classes are, or whether people transition between different classes across time. So those are all possible extensions of the latent profile model. If you want to learn more about this, there are more videos on latent profile analysis here on this channel where I show how to do this analysis in Mplus. I also offer workshops on latent profile and latent class and latent transition analysis via QuantFish, for which you can find the links in the description here under this video. Feel free to subscribe to this channel so you don't miss future videos, and I'll see you next time.